So I am Cecelia Martinez. I'm a developer advocate for Appflow by Ionic. Appflow is a mobile CI/CD platform. And you can find me on Twitter and GitHub at Cecelia Creates. You can also feel free to connect with me at LinkedIn. You can just find me by my name, Cecelia Martinez. So I'm here today to talk to you about mobile CI/CD because mobile deployments are complex, but traditional CI/CD isn't really designed for those specific complexities. What we have on the agenda today, we'll start by talking about what makes mobile different. Then we'll go through the different stages that you need to customize your CI/CD for mobile. And we'll also talk about some implementation options that you have if you are looking to implement a mobile CI/CD pipeline at your organization. All right, so we'll get started with what makes mobile different. Mobile applications are different across each and every phase of the deployment process. When we talk about testing, you're not just testing for a web application, you're testing across multiple build types and platforms. You also have to deal with device fragmentation. What we mean by that is that the support for devices goes back in two directions. It goes back in order to support oldest devices available, as well as the newest devices that are out there. You also need to manage test release channels. When you're testing your applications on mobile devices, you're not necessarily just dealing with one testing environment. You will likely have multiple stages of tests, and that will have different channels. And so those need to be maintained separately. And then you also need to consider your test logs and your feedback. Another reason that mobile is different is when it comes to the actual build process of your application. When you think of a web build, depending on what type of web application that you're building, typically you're running a build command. You may have some build dependencies that are required in that environment. But when you're talking about building for mobile applications, there's specific infrastructure hardware requirements. The big one is that if you'd like to build iOS apps, you need to have Mac hardware. And then you'll typically be using Linux for Android. You also have to maintain, because you have different infrastructure requirements, then you need to maintain your multiple different environments. And some of those may be unreliable because of different build stacks. When we talk about the build stack, what we're talking about is the specific dependencies required for that type of build. The build process is also very different for mobile because of build signing credentials. This process is different across iOS and Android, but it is required in order to create what's called a signed bundle to deploy to app stores. This means that you need to have those credentials available in whatever environment that you're building. Typically, if you're used to doing deployments manually, this may just be built into one of your developers' Xcode settings, and they create a signed bundle on their own machine. When you're doing this in a CI/CD environment, obviously you need to be able to get those credentials into that environment to create a signed build. And of course, mobile deployments are different from web because of the app stores. When you have a web app, you can pretty much push out whatever you like. You can deploy, there's nobody who has to approve it. You can ship as good or as bad of a web app as you like. But when it comes to mobile, there are app store asset requirements and the approval process. So you have to think about things like your store listing, the description and the assets for that, and also the approval process. There's also multiple release types and deployment channels. I mentioned this a little bit in the testing section, but it also comes to the shipping aspect as well. Whether you are doing an enterprise, an ad hoc, an app store, or other types of releases for iOS, or whether you're doing debug or in most cases, a release build for Android. And you also want to think about who has access on your team to developer accounts. What we typically tend to see is silos when it comes to mobile deployments at organizations, where only a few people are able to actually push the ship process forward. And so that's something to consider as well. And last but not least, I put maintaining as part of the deployment process. There may be some opinions on whether or not you actually consider that part of the deployment process, but I wanted to really talk about it because it's so different on mobile. In addition to having multiple devices that you need to support, you also have the long tail of app versions to support. What this means is if you deploy a change to your web app, everybody aside from maybe like, if you have feature flags or A/B testing, every user who then visits your web app is going to have the same experience as soon as that new version is released. When it comes to mobile applications, users may still be on an older version, and it's up to you to decide how long of versions back are you going to support. And so that really takes into because of that, you have to take into consideration what app versions you're supporting whenever you make changes to your app that could be interacting with older versions. There's also upkeep with App Store requirements. Recently, we've seen Android and Google, have new requirements for the type of binary that you're using for uploading. You have to target specific Android SDKs. If there are critical security or privacy requirements that go out, your app could be, delisted from the App Store if you're not up to date. This is different than a web app where you kind of control what updates you need to make to your own application. There's also the build infrastructure and dependency management. As I mentioned, you may have to target certain SDKs and make sure that your build stacks are up to date, and that requires a process, especially if you have different versions of your application, or if you're developing cross-platform versus having separate teams for each platform. You may have different processes for maintaining your build infrastructure and your dependencies. And then another thing about maintaining mobile applications is that bug fixes and updates are difficult to deploy. You can't push them out whenever you like because of that App Store approval process. It could take, a week, sometimes even more, in order to get an update out to your users. So what this means for you as a developer is that cross-functional knowledge is required for mobile deployments and developing a mobile CI/CD system. You need to not only understand DevOps and CI/CD, but also these specific intricacies of mobile deployments for both Android and iOS if you are supporting both platforms. It also means that you may have delayed releases across different platforms. So your users may have a very different experience between web, iOS, and Android, depending on how your systems are set up and how often you're releasing for those platforms. And of course, that goes into having a different developer experience and user experience across platform. I primarily work with cross-platform applications where you have a single code base that is being deployed across the different platforms. But if you have separate applications, then that is even more so amplified by having different DX and UX, because even if you have a streamlined system for deployments, the development process will be different across those teams. All right, so let's dig into customizing for mobile. All right, so the first step is going to be setting up your environments. As I mentioned, you will need to have Mac and Linux environments. Typically, what we'll see is if you are leveraging an existing CI/CD system, you already have a method for provisioning these environments. And you will essentially, whatever the same step that you use to provision them for your web app, you'll need to do that for mobile. However, most people are not using Mac environments, so that would need to be provisioned in addition to your existing set. Then you'll need to install your build dependencies. So our build dependencies look like, I'll kind of go into those in just a minute here. But the way that you install them could be either manually installed as part of your pipeline instructions, or you could use a container image that contains the version of the Android SDK that you'll need, Xcode, as well as if you have any dependencies to build the version of your application as well, such as Node if you're building a cross-platform application. And then you'll also need to consider environment variables. If you're using a platform that provides you with access to environment variables, this is typically how you will inject any kind of your signing credentials if you're using those, unless you're using a specific tool, a separate tool. It's also going to typically, there's different configuration options. For example, if you are building a test version of your app versus a production version or like a release version of your app, or maybe even an internal version, then you will typically use environment variables to change the configurations as part of that process in setting up your environment. I mentioned build stacks. So this is what the build stack looks like for Mac for Appflow. This is the CI/CD system, and this includes Node, Cordova, Ionic, because it's needs to also support building Ionic and Cordova apps. It also needs to support building React Native apps, and then we have Mac OS, CocoaPods, Xcode, and Carthage. In order to support doing the actual signed build for iOS. So these are the types of dependencies that you may need to install or have an image for in your environment. When we talk about build, so once you have your environment set up, then you need to essentially execute the actual build command. This is not going to be as simple as just how you might run like npm run build for web apps. So this is because for mobile applications, there's different build types. So for Android, I mentioned there are, we'll go into these in just a moment here, but there's different build types depending on the audience, the purpose, and then also the devices that the build can run on. You also need to have a version increment step. This will, every new build of your application, even if it is a test version, but especially if it's a version that's going to be submitted to app stores, needs to be versioned properly. You don't typically see this with web apps, so you'll need to ensure that you are versioning your app correctly before you submit it to the app store. And this takes place during the build step, right before the build step. Then it's signing keys and certificates. As I mentioned, for any type of build except for a debug build or for Android or a simulator build for iOS, you will need to generate a signed bundle with credentials. And that is required in order to be able to run the app on devices or submit to the App Store. And then there needs to be a step in order to access the build artifacts. These are the output AAB or APK files for Android, or the IPA and DSIM files for iOS. So, the next step is delivery. And so how are you going to access those build artifacts in order to get them to the right place? Let's dig in a little bit more into signing. So for Android, I mentioned that we have release and debug builds. For release builds, you will need what's called an upload key in order to generate a signed bundle. You use an upload key to sign the bundle, and then you use an app signing key later on after you've uploaded it to Google Play. So name is a little bit confusing there, but the upload key is generated on your local machine. You can either use Android Studio in order to generate a JKS or key store file, or you can use a tool called Key Tool that comes built in with the Android SDK. But that's going to generate a file, and then you'll also need to note some passwords that you'll use, because that key is used during the process to generate the signed bundle for Android. And then for iOS, you have what's called a signing certificate, which validates the identity and the authorization of the person who is creating the signed bundle, as well as a provisioning profile. And the provisioning profile states what devices the application can run on. So if you are doing a development, an ad hoc release, or an enterprise release, you need to specify the device IDs in the provisioning profile. If you are doing a production release, which is for the App Store, then you'll have a distribution provisioning profile, which does not specify devices, and it means that they can run on any device once approved. These are both generated in the Apple Developer Program website. So they are generated and then will need to then be exported and used in your environment when signing the application. So this is an example, this is from the GitHub docs of kind of a pipeline step to install the Apple certificate and provisioning profiles using environment variables and using GitHub secrets in GitHub. So they're typically like you would export the secret and then it's encoded, and during that process then it decodes the secret from the secret key, and installs it in the environment. And then the next step, which would be the build command, it'll make sure it'll use the provisioning profile and the signing certificate in order to generate that signed bundle. There are easier ways to do this as well, but I wanted to kind of give an example of what that would look like in order to do that manually, leveraging your secret keys in your environment. All right, and so next we have deployment. So you've set up your environment, you've created a sign bundle, and now you actually want to upload to the App Store. It's important to note that there are very, very few tools out there that will actually see the deployment all the way to release management at the very end. So if you want something where you'll automatically be completely pushed out to the App Store and ready to go for a release, not for test flight, then you'll need to use one of the you'll need to do some manual setup within using the app developer APIs. But you can upload and you can set the release types and tracks that you're uploading to from your deployment pipeline. You'll need to have your developer credentials either in the environment or using an API key if you're leveraging the API. You'll also need to set which release type or track that you are deploying to. And there's a variety of binary upload tools in order to get the sign bundle that was output in the last step up to the app stores. So we talk about test deployments. Typically, your app will go through multiple rounds of manual testing, and that will involve deploying to what's called testing tracks or internal testers. For Google Play, there are 3 testing tracks. There is internal, which is the only track where you can deploy unconfigured applications. You can deploy to up to 100 users. And so this is great for your internal like manual QA or sharing with stakeholders. There's alpha testing, which is also called closed testing track. This allows you to release to a wider audience, but still not fully public in the App Store. And then there is beta. By the time that you get to beta, you want to make sure that your app is ready to be listed and fully configured because it will show in the Google Play Store, but as beta. For the iOS side, you have ad hoc releases. Ad hoc releases allow you to deploy to up to 100 test devices per year. And then but you do have to list those out in your provisioning profile. So that's typically works well if you have some kind of device management system in place where you can get those device IDs for your internal testers. And there's also Test Flight. This is a program run by Apple that allows you to deploy to beta testers with either a email or a link. And it comes with tools built in order for testers to provide feedback, such as take screenshots or add notes and submit that directly back. So that can be a nice feedback loop once your app is at that stage. So I mentioned that there's some tools to make this process easier. There's one called Fastlane. It's built by Google. It's free open source tool. And it leverages what's called you create a fast file, which ends up looking a little bit kind of like a YAML file, as you can see here. But it gives you the ability to manage your signed credentials in your pipeline, as well as your credentials for the app stores in order to update. So you define steps within your fast file. Typically, they are, for example, in this one, we have a beta release and then a beta, and then we'll have a release step. Then from your CI/CD pipeline, you call that command. You say Fastlane beta, and that will run this step. As you can see for the beta step, we have incrementing the build number, then we're building the app and we're uploading to test flight. That's because this has already been pre-configured with your signing credentials and also your App Store credentials in order to do that. So this would actually upload directly to test flight, and you'd get an email from Apple, saying that your app is ready to go. For the release step, we have capturing screenshots, building your app, uploading to App Store, and there's even like a Slack notification option, for example, to notify when that has been completed. So using a tool like Fastlane can make it much easier for credential management and also writing out your steps in order to do your builds and your uploads. And then we'll talk about updates. So updates for your application, as I mentioned earlier, are going to be very different for mobile versus web. You may have a set release cadence, like every 2 weeks, or you may release more depending on when releases are ready. You may also want to think about what your strategy looks like for rollbacks and critical bug fixes. So because of the App Store approval process, as I mentioned, if something goes wrong and a critical bug is introduced to the environment or to the app, it could take, a week to get approval for a new version to go out. So having a very strong understanding of what the App Store approval process looks like can be critical when you do have a bug, in order to reduce that time as much as you can. You may also want to employ a strategy called live or over-the-air deployments. This allows you, if you're developing either cross-platform or if you have any web content built into your application, to push updates to the web content portion of your app without the App Store approval. You can't make any native changes, but what this is that there's various tools available. Some of them are specific to a platform, like React Native has a tool for this. If you are using Ionic or Cordova, there's a tool for that. If you have mobile micro front ends with embedded web content, you can push changes to those embedded micro front ends without changing the native application itself. That can be a strategy for getting updates out faster. Your app does have to be pre-configured for these changes. You can't just decide to do it and then do it on the fly. Your native app version does have to be configured to receive these types of updates, but you may want to consider that as a strategy if you are concerned about the App Store approval process delaying releases. And then I mentioned maintenance earlier. I won't spend too much time on this given the time, but you do have to consider your development and build stack requirements. Your certificates and credentials do expire, so they do need to be renewed and updated. Ideally, you already have a process in place for rotating out your secrets in your CI/CD environment, and the certificates and credentials would be included in that. And then also ensuring that your build environments are up to date with those most recent build stacks. Okay, and then finally, there's some implementation options for building out your own mobile CI/CD system. And when I talk about implementation options, I mean the method in which you take all the steps that we just covered and get started at your organization. It is okay to start small. You don't necessarily need to build out for every platform at once. You don't need to build out for every release type at once. You may, for example, want to start with just implementing a CI/CD pipeline for the test versions of your app to test flight, and get a sense of how that works, and then move forward with doing and keep your production releases manual at first before moving on and expanding where you have CI/CD set up for your deployments. So one implementation option is to upgrade your existing CI/CD. This requires taking your existing team, your CI/CD or DevOps team, and just educating additional provisioning for mobile requirements. This means adding Mac into the equation. It means adding those build stacks into the equation. It means understanding defining out new pipeline or fastlane files if you're going to use that, and what will trigger them. It also means additional credentials management in order to have the signing credentials and the developer credentials as well. It's good to implement systems and processes to support mobile deployments across teams. Most organizations do not. They will have multiple teams, an iOS team, a native, an Android team. Maybe they do have a cross-platform team as well. Maybe they have all of the above. But if you're going to have a centralized DevOps team that's handling all mobile deployments, there needs to be a system in place for each of these different teams to ensure that they have their own build stacks available for provisioning when it's time to build their applications. And then you may also need to, increase resources to speed up releases. Mobile builds can take a little bit of time. You're compiling a native binary, so that's something to consider as well versus your web builds. You may end up taking more machine resources than you anticipate if they're area that you're not used to. Another option is to let mobile dev teams manage their own deployment processes. In this case, you have a bit more of a knowledge silo because each team will own their own processes. However, in this case, then you don't necessarily need to plan for have the knowledge or expertise or the resources for every single type of platform or application. For example, your iOS team can manage them independently. Your Android team can manage them independently. They would provision and manage their own resources. And if you do have any organization-wide compliance or security and vendor requirements, then those would need to be implemented for each team and make sure that each team is following those rather than having a centralized location. So this may be better if you either are a smaller organization or you already have a dedicated expert on your mobile team that can run with the can coordinate and own that deployment process. This can sometimes, though, create, a bus problem where a developer gets on a bus and leaves town and you're not able to deploy without the credentials that are on their machine or that they have. And so that's kind of something else to consider, is ensuring that you have redundancies in place if you are letting the teams manage their own deployments. And then you can also leverage a mobile CI/CD platform. There's a variety of options. Some of them are platform specific, like Xcode Cloud. Some of them are framework specific, like if you're using React Native Expo, there's Expo Build, EAS. And then there's also general mobile CI/CD platforms that are essentially like support multiple platforms. And they have different types that will support either like simple builds and deployments all the way up to very complex pipelines that include testing, release management, and everything. So this provides consistent tooling across teams and a centralized environment. Typically, these allow you to upload your signing credentials and your app store. They connect with app stores directly. You also, have cloud provisioning and management, but there's varying levels of customization and complexity required. Some tools are very complex, and some tools may not have everything that you need. So you may end up having to fall back on some manual steps in order to accomplish everything in the pipeline that you're looking to accomplish. So that's something to take into consideration when reviewing the potential tools. So just to recap, we talked about what makes mobile different. And this is really primarily due to the platform itself. There's infrastructure requirements, there's signed builds, and there's also deploying to app stores. We talked about customizing your CI/CD for mobile, including steps that you need to take to prepare your environments, the build step, the uploading to app stores, and then also maintaining and sending updates. And then we also talked about implementation options, which include using your existing CI/CD infrastructure in a centralized team, letting mobile development teams manage their own deployments, or using a tool across the organization. And thank you so much. I appreciate everyone for being here, and I'm happy to answer any questions. If you have any questions, you can also reach out to me at Cecelia Creates on Twitter and GitHub, or devrel@ionic.io. And we also do have documentation and everything at useappflow.com. Yeah, so Azure DevOps is an example of a kind of what we consider more of like a traditional CI/CD tool, but that has added in functionality for mobile. We're increasingly seeing this where existing, like Circle CI, for example, has some mobile support that they've added. So Azure DevOps does have some steps that are useful for deploying Flutter applications. I haven't used them myself, but we have seen that sometimes when it comes down to anything that's built into your CI/CD system, it's going to be a trade-off of ease versus configurability, right? And so if the steps are able to accomplish what you need, then you're great. You may have to augment those with some customized steps if you did need to do anything separately. However, Flutter applications, because they're cross-platform, they're designed to just be built from one code base. So unless you have very specific differences across the different platforms, which are usually handled during the development process, and you configure those inside your code base, not during the DevOps process for Flutter, then you should be able to use the built-in tools as long as they accomplish your needs.
Mm-hmm. And another question again from Mr. Villavartiainen. Any way to accommodate for potential device-specific variation / quirks other than a device farm for testing?
Not really. That's why it's so complex, is because you really do need to obviously there's virtual device testing, but that's not going to give you the true fidelity of real devices. And so I would say as you continue to think about your device matrix of the devices that you support and you identify edge cases across those specific devices, you may be able to scale back on some real device testing as long as those edge cases are covered. But in reality, the reason that those exist is because it is very complex to recreate those specific hardware configurations on a virtual device. And so if you do, I would, that's why you go through a lot of rounds of testing to uncover any of those edge cases. It also may be worth really evaluating what devices that you support. I tend to defer to wanting to support as many users and devices as possible and be accessible as possible. And so that's why we see a couple of things with cross-platform, because it's designed for the web. It's not going to give you everything that you need for every single app. It's going to be very dependent on what you're building. But that may be a way for you to kind of ensure a little bit more cross-platform stability.
So any recommendations for opting into Play App Sign while having an existing app on the store?
Yes. So if you would like, so once you move to kind of like the AAB bundles, now you have option to Play App Signing. You can do this with an existing app in Google Play. So Play App Signing, that's what I was talking about, that app signing key, where Google Play actually generates and manages this for you. If you already have an existing app on the store, you may already have an existing app signing key. You can still provide that app signing key during the sign-up process for Play App Signing in order to keep that consistent, because the app signing key is for the life of the application. So if you already have one that you're using and you'd like to opt into Play App Signing going forward, you can provide your own key as well. So you don't have to generate a new one. So that might be an option for you if you want to manage, if you already have an existing one.
Then another one on using GitHub Actions, and whether are there any pre-built GitHub Actions for building and deploying?
Oh, building and deploying. Yes. Yeah. So GitHub Action does have a lot of available actions. I know specifically for there's a signing a Android bundle action. There is a signing an iOS signing an iOS GitHub action, and those will essentially use the same process where you have your signing credentials in your GitHub secrets, but you don't have to apply them manually like in that example that I showed. Instead, it takes that in as your parameters for the GitHub action. There are also a number of, I know for React Native, there's a lot of React Native GitHub action steps as well available. And so I would recommend leveraging the existing library rather than building it out from scratch, unless you have very specific configuration needs. But in most cases, that's going to give you what you need. Really, the only thing that may prevent you from being able to use a GitHub action is if you are passing a lot of environment variables during the build step for some reason. However, most of the times we recommend using configuration files in order to bypass that.
Hi, we're from Efficode,
who brings you the DEVOPS Conference.
Continuous delivery has been a key focus for over a decade, and platform engineering is its natural evolution.
If you want to remove the pain and uncertainty from your software development, we'd love to help you.
Discover more at efficode.com
and enjoy the insightful sessions at the DEVOPS Conference.